Okay, in this video we're going to discuss parallelograms. And parallelograms are a type of quadrilateral that has some special characteristics, but they're not just like a square and they're not necessarily just like a rectangle. Though those are types of parallelograms, a parallelogram can be tilted to one side or the other. Now what it really means is we have to look at sets of sides. For example, this side right here is moving the exact same direction as that side. They're parallel. And then over here on top, that side is moving the exact same direction as the bottom side. And one of those consequences of this now, since we have two sets of parallel sides, is that basically this side over here on the right has to be the same length exactly as the other side. If it's not, then it'd be impossible for my top and bottom to connect them and still be moving in parallel directions also. So the first thing you need to recognize about parallelograms is the bottom will match the length of the top, and each side will match the length of each other. Now the other part of this we need to get into, there's two aspects of parallelograms you need to understand. First would be the angle relationships in those. Now if I were to draw what we call a diagonal, which goes from one corner to the other, what I would really be drawing, if you think about it, is what you know as a transversal that cuts through two parallel lines. Okay? And what that means is this right here, this angle, would have to be the same as this one down there. Okay? And then this angle over here would have to be the same as this angle right here. And that doesn't mean the purple one and the orange one have to be the same as each other. We're not saying that it gets bisected here. What we're saying is it does cut through the parallel lines, and so we could kind of pretend that the red sides aren't even there, and we can see that alternating angles are going to be the same. Now, if I had the transversal on the other side, there's also some things I can notice about that. When we draw these diagonals, okay, and they basically intersect in the middle of this thing, each diagonal is perfectly cut in half. So if you have a parallelogram with some numbers on it, for example, let's say this said 2x plus 10, and over here this said 40. Okay? What we could say is that since these are diagonals, they're getting cut in half by each other, so this segment right here would have to be the same as this segment right there, and we can set up something to figure that out. 2x plus 10 has to equal 40. Okay? And we can solve that now, and you could subtract 10 and do your normal algebra on this and figure out what that missing value is. Okay? 2x would have to be 30, so x equals 15. Okay? Now if I were to see that on the other side, for example, let's say we saw 50 over here and 4x plus 2 over there, we could set up the same kind of relationship. 4x plus 2 equals 50. Okay? So you could go through your process right there, and actually this probably wouldn't be an x, it would be a y, so we have two completely different variables in there. I shouldn't have written x, should be a y. But that's not the point. The point is you can look at these segments and see that the diagonals bisect each other, which means one half is exactly the same as the other half. Now don't necessarily take that concept and expand it and assume that it works for the entire parallelogram in other aspects. What I mean by that is, like we said before, this purple angle is the same as this purple angle, but that does not mean that it's the same as the orange angle over here. Those don't have to be the same way. If they were rectangles or squares, then yes, they would be. But since it's not, we don't know exactly how far this thing is tilted. Now, that's just the basics on parallelograms. You should know some things just by looking at this. You should be able to see that the sides are going to be the same as each other. So each set of sides is going to be the same length. And the diagonals are going to get split in half. So one half is the same as the other half. And if you know that, you probably know enough to solve for any missing measurement that's within these.